Hello to anyone who's watching this. I am going to go through some of the week 6 slides and some announcements about where we're going from here. So feel free to watch this whole video. It'll be about 10 minutes long. So this week we're in week 6. We are shifting from one type of wave to another, and we're going to be going more into light waves and the electromagnetic spectrum. So I'm going to go over a couple of announcements before I start my notes and move my little bubble up here. So just like always, you have your to-do list. I'm sorry, I think last week I had your biology list on yours, but this week it should be for you. So first of all, make sure you've done all of your previous lessons. We've had 7 at this point, so make sure those are all done with both the focus question and the exit question for each week. If you're doing them week by week, you turn them in, and then I release them on Mondays for you. So still use that one document, still the same one. It's called sound unit, and even though we're going into light waves, it's still all a part of the same unit. And a reminder that when you finish each week, so when you finish this week, to turn it in so I can check your progress. And eventually when you finish next week, which is our last week of new material, I will grade those for you to have in the grade book. The other thing that you should do that is already in the grade book is taking each week's quiz. So go through and do that. If you haven't already, there have been 4 quizzes at this point. We didn't do one for the speed of sound lab. So you should have 4 quizzes, weeks 1, 2, 3, and then last week we had one as well, week 5. You can also retake those, but I highly recommend, I'm only going to allow you to do it once. So make sure that you are ready when you do the retake, or else I will not allow you to take it again. So if you keep trying, a lot of people try it once, try it again, get a 1, try it a third time, get a 2. It tells you what the right answers are, so it should really not be that hard for you to get a perfect score after the second try. And then the other thing is that your speed of sound lab, which was for week 4, so 2 weeks ago we did that, is due this Friday. So you want to make sure that you're finishing that up if you haven't already, because that is going to be a big grade. If you're missing things from before this shutdown, especially labs, this can definitely help bring your grade up. So make sure you do that, because this is going to be a good thing to boost your grade up. And if you have any problems with that, I've posted a few videos and tutorials on how to do that. So please reach out if you're confused. Here's the recommended schedule for the week. It's kind of back to normal. So if you're viewing this on Monday, you can just take today to look over the notes, look at the video, and then you can jump into the activities for the rest of the week, finishing up with your quiz on Friday. Got your expectations, reminder of how to use Google Classroom, your meetings. I've added a link to go to the document that has all your meeting links on there. So I'd love to see some of you. I haven't had many physics people joining recently, but it's always good to talk to you. So now we're getting into our weekly notes. So like I said, we have finished up with our sound waves, and we are now getting into light. I'm going to close my face for a little bit. So a couple of things that we can kind of review for this. We've talked about sound waves, which are longitudinal or compressional, meaning that it's the compressions of particles that is causing it to travel. However, light waves are transverse waves. So that's like these little up and down waves that we've been looking at a lot. And they do not need a medium to travel. So that's why we have all the types of radiation that comes from space, from the sun, like light and heat, infrared, can travel through the vacuum of space and still get to us. There's also a lot of other types of waves we'll learn about this week that we can use to travel through a vacuum, or just to travel within objects. So that'll be the first lesson of the week, number 8. So when we look at this, all the different types, and there's 7 main categories of light wave radiation, fit into what we call the electromagnetic spectrum. So this is something you've hopefully seen before, and we arrange it from lowest wavelength to highest wavelength, longest wavelength to shortest wavelength, or lowest frequency to highest frequency, or it can be flipped. It doesn't really matter as long as you have it as a spectrum going from long to short, or from short to long. So right here you can see that you have the longest waves here, which are your radio waves, all the way down to the shortest wavelength waves, which are your gamma rays. So that's something to get familiar with again if you're not familiar already. This is a nice video of an introduction to this, and you'll also have access to short videos also from NASA for each of the 7 types of waves throughout this presentation. So a couple things to recap if you have watched that video or if you've learned about this before. The range of all types of EM radiation is the electromagnetic spectrum. And radiation, just that word radiation, isn't always a bad thing. It just is the word we use to describe energy that travels. So waves, basically, specifically EM waves. We usually don't call sound waves radiation. And so you think of like the origin of that word, ray, usually has to do with spreading out from an original source. You can think of rays in like math are like lines or arrows that are going outwards. So when we're talking about all the different types of electromagnetic radiation, we usually think of sometimes radiating as just our visible light that we can see, but there are 6 other types of light that are invisible to the naked eye, but we definitely use and experience a lot. So radio waves, for example, is another type, and you'll get to see all the other types as well. Other reminder, these are transverse waves. That's the type of wave where it looks like this, little squigglies, ups and downs, and they do not need a medium to travel. So that's just a recap. Measuring, this is important. So just like with sound waves, we are going to be using a couple of standard measurements to talk about the behavior and characteristics of the waves. The first one being frequency. So again, we're going to look at this in hertz. So for frequency, you can see the closer together the waves are, the higher the frequency. So the highest frequency here would be a gamma ray, lowest frequency, radio waves. Wavelength also is going to be important, and that's looking at the distance of a wave from peak to peak or crest to crest. So again, you have your longer wavelengths over here, radio waves, shorter wavelengths over here, gamma rays. And with that, energy. So this is something we looked at with amplitude with sound, but we also can use frequency to talk about how much energy a wave carries. And the basic pattern that we're going to look at here is that if we have low frequency, that's going to mean long wavelengths and low energy. So radio waves are actually pretty long. If you look at the approximate scale here, they can jump over houses and buildings. They're extremely long. Getting into microwaves, which are small, but not extremely small as you would think from their name. They're about the size of like a penny or a butterfly or something small like that. Getting into infrared, which are heat waves, and so on. As we get further to this side of the spectrum, the other half of the visible light middle point, we get into our higher frequency waves, which are short wavelengths, and these have the highest energy. So when you look at the ones on this side, these are the ones that we've always kind of been wary of. When we talk about radiation, these are ones we want to stay away from because they have higher energy and shorter wavelength, meaning that they can penetrate through things that are this small. So anything that is smaller or shorter, smaller than visible light, so ultraviolet, X-rays, gamma rays, can go through a human cell or any animal cell, molecules, and they're small as atoms. So that's why we have to be careful with ultraviolet or UV light, as well as X-rays and gamma rays. But what you'll learn later is that these can also be really useful types of radiation for different technologies. So if you want to take some time to play around with this website, actually I have to add the link still, but it'll be there for you. You can go through this website and explore and find the different types of waves and where they fall and kind of compare them to everyday objects. I added a little picture here because I know on my browser, and I'm sure on a lot of yours, it's probably going to block it because it uses a flash player. You just have to click through and change some settings to make it allow you to see that. So I added some pictures to help you out with that. All right, and that's the basics of the EM spectrum. Within each of your activities, you're going to have additional notes. So activity number 8 is going to be focusing on the EM spectrum. And what you're going to do is you're going to be researching 2 different types of waves and a technology that goes with them, and use the information that you learn to explain how that wave is used in that technology and how the behavior or the frequency or wavelength helps to use that. So for example, you could say gamma rays are used for whatever medical technology, which is useful because they're so short that they can penetrate through skin. So that would be an example of explaining how the behavior relates to the use. So what you're going to do for this is you're going to choose 2 different types of waves, one from each category, one that's low energy, so lower than light or visible light. So that would be either radio waves, microwaves, or infrared. So if you're like, I love my microwave oven, I'm going to research how that works. Sounds like fun. And then you're going to also choose one from a high energy side of the spectrum. So either UV, ultraviolet, X-rays, or gamma rays. So I've given you a bunch of links. These are all videos from that NASA, same video as the intro, as well as a few other links. So you can use those to research, and just make sure for your exit question, you're writing at least a couple of sentences for the 2 different types of waves. Your second activity this week is kind of fun. It's looking at the middle part of the spectrum that I kind of skipped over in activity 8, the visible light spectrum. And when we look at the visible light spectrum, we see colors. So if you break down this tiny part of the spectrum, you see the entire rainbow of colors. So what you're going to be doing for this is playing around with a simulation and learning about how light colors can mix to make different other colors. So I have some videos here, some notes on how colors work, light colors versus pigments. So pigments are going to be the types of colors that are more opaque. You cannot see them. They reflect light rather than transmit it. There's a couple videos to help you learn about that, and there's a lot of notes. So although you won't not be writing down the notes necessarily, these might be helpful for you to understand the activity as a whole. I definitely recommend presenting it so that you can actually see all the pictures. And it's kind of cool. You can find some other applications of this with how pixels and LCD screens work, as well as there's a video there. And then you can also look at how pigments mix. And so if you're into art or paint, that's a cool offshoot from what we're learning here. So I'll let you guys go through this. There's a nice little video. I would usually do this kind of a demonstration in class, but because we won't be together, this video will do the trick. And then here is the instructions on how to get this part open. So I'll actually pull it up for you and show you how to use it. Hopefully you don't have any problems running this. Again, if you need to, I don't think it uses Flash, but if it does, you can try to activate that and let me know if you still can't get it to work. So what you're gonna do here is you have this, you're gonna click the RBG one. So you have your red, green, and your blue lights. These are the 3 primary light colors, which you'll learn about in your notes. And you're going to try to get this observer to view different colors. So some of them will be easy, right? If you want her to view red, you'll just turn red all the way up. If you want them to see green, you'll just turn green all the way up. But say you're trying to get to yellow, you can kind of play around and see what 2 colors would make a yellow color. So this makes more of a turquoise. I'm going to turn this down. And then when you find it, that looks pretty yellow to me. You can fiddle around with it a little bit to make it a good shade. You're going to look at where those toggles are on the switch and write down or put in your packet what percentage of light you used for each of those. So for example, right now I made yellow and it looks like it's about 50% on for red and about 50% on for green. They should add up to 100, and that should make it easy. So you're gonna put that in your packet for all the colors of the rainbow, red all the way down to violet. So might be a little challenging, but it'll be fun to play around and mix some light colors. All right. And I'm going to end it there. So that's your introduction video for this week, and I hope you have a fun time with some of that stuff. If you have any questions, please let me know, and hopefully I'll see some of you at our meeting this week.